Hello and welcome to a lesson on compound interest and depreciation. These are two topics that occur on the higher tier GCSE syllabus. We look at 4 examples of compound interest and then we look at 4 examples of depreciation. To begin, compound interest. Find the amount in the bank when £5,000 is invested at 4% per annum for 2 years. That means you get 4% interest each year. Now, usually compound interest questions are on the calculator exam, but if the arithmetic is as simple as it is here, it can also be on the non-calculator exam. So we'll have a look at this question twice, once without a calculator and once with a calculator. So if we take our £5,000 and put it in the bank, in year 1 we get 4% interest. Well, 1% of £5,000 divided by 100 we see is £50. So 4% is 4 lots of 50, £200. So the interest in that first year is £200. And that gets added to what's already there. And so at the end of year 1 there's £5,200 in the bank. Now in year 2, again the interest is 4%, but this time it's based on this figure here. So 1% of 5,200 is £52, 4% is 4 lots of £52, £208. So the interest this year is 208. That is added to what's already there, and the final bank balance after 2 years will be £5,408. Now, using a calculator, we can do this much more simply. We can take our £5,000 and at the end of the first year we want to add 4%, so we multiply by 1.04. Now this is the amount in the bank, and at the end of the second year we need to multiply this by 1.04. So you can see that the answer is actually obtained by multiplying the original amount we call the principal, £5,000, by 1.04 squared. And if we do that on a calculator, 5,000 multiplied by, and on this particular calculator I need to put it in a pair of brackets. You don't on most calculators, but 1.04 squared. And that comes to 5,408, the same answer. Moving on to example 2, which again we'll do twice, once without a calculator, once with a calculator. Find the amount in the bank when £800 is invested at 10% per annum for 3 years. So 800 goes in the bank, and in year 1, 10% interest. 10% of 800 is 80. So that means at the end of year 1 there will be £880 in the account. Next, year 2, 10% interest. 10% of £880 is £88. So when that is added to what's already there, we get £968. Year 3, 10% of £968 is £96.80. £96.80. So we add that to what's already there. 8 and 6 is 14, carry the 1, 9 and 1's 10 and 6 is 16, carry the 1, 9 and 1's 10. £1,064.80. And that's about as complicated as it would get on the non-calculator paper. Using a calculator, after 1 year, to add on 10%, we'd multiply by 1.10. Then at the end of the next year, we'd take that figure that's in the bank and multiply that by 1.10. And we'd do exactly the same at the end of the third year. So we see a formula developing here now. It's actually the amount you put in multiplied by 1.10 to the power of the number of years it's in this case 3. 1.10 cubed. So I've got £800 multiplied by, I have to put it in brackets, 1.10, and I use the YX button and then say to the power 3, close the bracket, and it comes to 1064.8, which is £1,064.80. For our next two examples, we'll just use one method, the calculator method. And we'll begin by writing down a formula. We can say that the amount in the bank is equal to the principal that we invest multiplied by 1 plus r over 100 to the power n. Now here r is the rate of interest and n is the number of years. Now it doesn't look particularly familiar to what we've been doing, but it's very difficult to write a formula with a decimal involved. And if we were using 4% as we did in the first one, 1 plus 4 hundredths is 1.04. So we don't actually use it with a fraction involved in the formula, we convert it to a decimal. When we had 10%, 1 plus 10 hundredths was 1.10. We'll see how we do with this one. Find the amount in the bank when £2,500 is invested at 6% per annum for 7 years. Well, A is equal to £2,500, that's the P, the principal, multiplied by, now 1 plus 6 over 100, it's 1.06, that's what you multiply by to add on 6%, 1.06. But because we've got the money in the bank for 7 years, we have to multiply by 1.06 at the end of every year, so it's 1.06 to the power 7. Now I use the calculator. 2,500 multiplied by, and I put in brackets, 1.06 raised to the power 7, close my brackets, equals £3,759.08 to the nearest penny. £3,759.08. £3,759.08. Moving on to example 4. Let's write the formula down again. A is equal to the principal multiplied by 1 plus r over 100 to the power n. This time we're investing £4,000 at 12% per annum for 25 years. So the amount that would be in the bank would be £4,000 multiplied by, now then, 12%, if we're adding on 12%, it's 1.12, which again, if you put the 12 in there, 1 plus 12 hundredths is 1.12. And this time it's to the power 25, leaving it in the bank for 25 years. What does that give us? 4,000 multiplied by 1.12 to the power 25 equals 68,026 pence. 68,026p. So you can see if you've got a high rate of interest and you leave money in the bank for a long time, this effect of compound interest, getting interest on the interest, can lead to staggering amounts over a long period of time. And that concludes the work on compound interest. We'll now look at depreciation. Depreciation is when something loses its value over time, perhaps because it's becoming worn out. Example: find the value of a 2-year-old motorcycle if it cost £4,000 new and depreciated by 25% per annum. So that means that at the end of any given year, it's worth 25% less than it was at the start of that year. So rather like compound interest, the figure on which we base in the percentage changes each year. And again, like compound interest, questions like this can be on the non-calculator paper if the arithmetic is straightforward. So the first two examples we'll do twice each using non-calculator methods and calculator methods. So we begin with our £4,000 motorcycle. £4,000 new. What happens during year one? Well, it depreciates by 25%, so it loses 25% of its value. 25% is a quarter, and a quarter of £4,000 is £1,000. So this motorcycle is going to lose £1,000 of its value during the first year, which means at the end of year one, it's worth £3,000. Now in year two, it's going to lose 25% of this value. 25%, a quarter of 3,000, is 750. So if we take that away, we find its value at the end of year two is £2,250. Now let's work it out using a calculator. We start with £4,000. And at the end of the first year, I need to take 25% off. Well, if I take 25% off, there'll be 75% left. So to find 75% of 4,000, we multiply by 0.75. And then at the end of the second year, we take this figure and take off 25%. And to do that, again, we multiply by 0.75. So you can see the similarities with compound interest calculations. This is equal to £4,000 multiplied by 0.75 squared. If we do that on the calculator, 4,000 multiplied by 0.75 squared equals 2,250. Moving on now to example 6, the second one of the depreciation ones. Find the value of a 3-year-old car if it costs £9,000 new and depreciated by 10% per annum. So we've got our £9,000 car, and in year one it's going to lose 10% of its value. 10% of 9,000 is 900. So what's it worth at the end of year one? 8,100. Year two, it's going to lose 10% of 8,100, which is 810. And so we've got 0 take away 0 is 0. 0 take away 1 I can't, so we'll borrow that one there. 10 take away 1 is 9. Borrow 1 from here. 10 take away 8 is 2. £7,290. Year 3 is going to lose 10% of 7,290, which is 729. Take it away, we need to borrow one of those and leave 8. 10 take away 9 is 1. 8 take away 2 is 6. We need to borrow 1 from here. 12 take away 7 is 5. £6,561. And again, that's about as difficult as it could get on the non-calculator paper. With a calculator, we'll be taking our £9,000, and if we wish to take off 10% at the end of the first year, we'd multiply by 0.90. In other words, we'd find 90%. But we'd have to do the same at the end of the second year, and we'd have to do the same at the end of the third year. So what we get is £9,000 multiplied by 0.90 to the power 3, if it's for 3 years. £9,000 multiplied by 0.90 to the power 3. Answer, £6,561. And that concludes example 6. Now the last 2 examples we'll just do by calculator. Let's try and write down a formula for this. The value of the depreciated item is equal to the principal that you spend on it in the first place, and this time instead of 1 plus r over 100, it's 1 minus r over 100 to the power n. That's how you take off r% and multiply by that percentage that's left each year. So it's to the power n because you're doing it for n years. So find the value of a 7-year-old factory machine if it cost £145,000 new and depreciated by 15% per annum. Well, the value would be the amount you paid for it, £145,000, multiplied by, now we're trying to take off 15%, so we're multiplying by 0.85 every year. How many years? 7. So it's multiplied by 0.85 to the power 7. £145,000 multiplied by 0.85 to the power 7 equals £46,483.68. Well, let's give it to the nearest pound. That's £46,484. £46,484. One final example. Find the value of a 10-year-old factory machine if it costs £750,000 new and depreciated by 28% per annum. Let's write down our formula. The value would be the principal multiplied by 1 minus r over 100 to the power n. So in this case, the value will be £750,000 multiplied by, now we try to take off 28% per annum. If you take off 28%, there's 72% left. So to find 72%, I multiply by 0.72, and it's for 10 years, so it's to the power 10. Notice if I put 28 in there for r, 28 hundredths, 1 minus 28 hundredths is 72 hundredths, which is a decimal is 0.72. So we've got 750,000 multiplied by 0.72 to the power 10, and to the nearest pound that's going to be 28,079 pounds. 28,079 pounds. Not worth very much compared with the 750,000 pounds that it was new. Right, that concludes this lesson on compound interest and depreciation. You'll now find an exercise with plenty of questions on both techniques.